the 45 degrees, right?
Yeah, well, 45 degrees and 90, so we'll just do 2. So if I give you, let's do tangent. No, that's not tangent. Let's do sine of theta is, we'll write it as square root of 2 over 2. And that looks a little funny. So that's not one of the triangles I'm thinking about. Curtis, question? So let's finish up with this one. Since the triangle that we're thinking about is a 1, 1 square root of 2, because I see square root of 2, that's probably going to be 45. You want to rewrite this as 1 over square root of 2. Okay, and if you look at your previous notes, we talked about how we went from here to here. So the opposite side is 1, and the hypotenuse is square root of 2. Sine is positive in quadrant 1 and 2. All students take calculus, in case you forget. And we said opposite side is 1, opposite is 1. See, this is the opposite of my reference angle. And the hypotenuse is square root of 2. We know the triangle, that's a 1, 1 square root of 2. Going to the left, we have to remember there's a negative sign on the second quadrant one. 45, 45. So the first triangle is always easy, that's just 45 degrees. The second one, we have to crawl to the other side. That's going to be short by 45. So 180 minus 45 is actually 135 degrees. So theta here is 135 and 45. So let's go ahead and do one more. Let's do sine of 0, theta equals to 0. Okay. Now, whenever you see an angle that's 0, 90, 180, 270, or 360, you might be, Mr. Cole, am I really supposed to memorize them all? No, just, can I divide it by 9? And actually, that's a trick. Can I divide it by 9? If I can divide by 9, it's going to be a 90-degree triangle. So 0 over 1, opposite over hypotenuse. So either you remembered what the sine of 0 is, or let's draw it out. Sine is positive 0 in quadrants 1 and 2. So this is kind of a trick question. Opposite is 0, 0, hypotenuse is 1, 1. This is automatically going to be what special triangle? A 0, 1, 1 triangle. Now I want you guys to actually see this. Is it true that I can have a triangle with a side of 0? That doesn't make any sense, right? So think of this as a mousetrap. Here's your mousetrap. Here's a little tiny mouse. Let's see. Oops. Little tiny mouse. And what happens to the mouse? It's going to get killed by the mousetrap. Look, crush. So it crushes down because there is no height. There is no height. That means the point is actually on the floor. That's the angle. Look on the left side. Is there really a height here? Nope. This comes crashing down also. It's flat on the floor. So theta could be 0 as well as 180 degrees. In radians, that's going to be 0 or pi. Now just to prove that to you, if I take 0 and I sine it, that's going to be 0. And if I take 180 and I sine it, that'll still be 0. Okay. Now you could also have drawn this. This is helpful to some people. A point on the 90-degree marks, this would be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. These are the x and y values. So sine is 0, cosine, sorry, whoops, wrong way. That was weird. Cosine is 0, cosine is 1, sine is 0. Cosine is 0 at 90 degrees, and sine is 1. It's standing straight up. The y value is up. Going to the left, the cosine is negative 1 at 180 degrees, and the sine is 0. Like we said, the sine is 0 at 180 degrees. The cosine is 0 at 270, and the sine is negative 1. The y value is negative 1. You can also memorize that. That's actually pretty quick too. But if you can't, draw the circle, draw the cross, draw the triangles. It does work. Okay, now to go backwards for cosecant secant, if I write cosecant of theta is cosecant is 2 over square root of 3. You could also write this as 2 square root of 3 over 3. So if they write it this way, you want to go back to this way. To remind yourself that cosecant is really 1 over sine. It is the reciprocal of sine. It is hypotenuse over opposite. Secant is really 1 over cosine because it is hypotenuse over adjacent. And cotangent is 1 over tangent, which is adjacent over opposite. Okay, those are the 3 reciprocal identities. Reciprocal identities. Okay. Now, so draw the cross like we typically would. Draw the cross. Now let me ask you this question. For cosecant, was cosecant sine, cosine, or tangent? Well, cosecant is hypotenuse over opposite. Hypotenuse over opposite. That's sine. When is sine positive? In quadrants 1 and 2. All students. Hypotenuse is 2. Opposite of square root of 3. Hypotenuse is 2. Opposite of square root of 3. What do you think the third side of the triangle is going to be? 2 square root of 3. Third side has to be 1. The left triangle in quadrant 2 is negative for 1 because we went left. What angle goes next to the 1? Oh, it's going to be 60. 60. So we have our first angle is going to be 60. Our second angle is going to be 120. Beta is 120 and 60. So whenever we have the reciprocal, we have to say, is that sine, cosine, or tangent? So we know which triangle to draw in what quadrant. Let's give you another one. If I write secant, theta is square root of 2. There's your code. Where's the fraction? If you don't see a fraction, go ahead and always write an invisible 1 on the bottom. Secant. So if I draw the cross, all students take calculus. It doesn't talk anything about secant, cosecant, cotangent. Well, secant's related to cosine because it's just hypotenuse over adjacent. That's cosine. So cosine's positive in quadrants 1 and 4. Adjacent is square root of 2. Whoops. Hypotenuse is square root of 2. Hypotenuse is square root of 2. And adjacent is positive 1. Opposite is going to be 1 also. It's a 1, 1 square root of 2 triangle. It's a 1. I oftentimes, for cosine, just write it right in the middle because it's the same side. What angle goes next to the 1? Is it the 30 or the 60? In this case, none. This is a 1, 1 square root of 2. It's actually 45. 45, 45. So this triangle, first angle, counting from 0, that's 45 degrees. Getting all the way around to the next angle, go all the way around the block. That's what we call 315. 315. 360 minus 45 is 315. Okay. On your homework, they wanted you to do this with a calculator. So they'll give you something like the cosine of theta is equal to 0.6. What angle would give you 0.6? Well, 0.6 isn't a fraction that we know. It's not a decimal that we know. So what you do is we have to use inverse operations. Inverse operations. Now, you learned in Algebra 1 that when you want to undo a square, you take the square root. That's an operation that we learned, an undo operation. The opposite of multiply is divide, right? Opposite of multiply is divide. So the inverse operation, and you'll learn this in geometry hopefully, that if I want to undo a cosine of theta, we have to do the inverse, cosine inverse of theta to both sides. Sometimes you guys will call this arc cosine. Arc cosine, for us, effectively the same thing. So opposite operations cancel each other out. So careful, we didn't cancel everything. We just got rid of cosine, so we still have theta left over. Cosine inverse of 0.6. Now, I don't know what the cosine inverse of 0.6. So this is where the calculator comes in. I'm going to write. So the way you use your calculator, you first type 0.6. And if you look at my left-hand corner here, we have cosine and sine. And on top, we have the inverses. So how do we get to inverses? You have to hit shift. All of a sudden, cosine inverse is now the actual button. We're going to undo our cosine. And that tells us it's going to be a 53.13 degree angle. 53.13 degree angle. So theta is 53.13 degrees. If they told us to do this in radians, if this was in radians, on the calculator, let's go back to the calculator. If you notice in the upper right hand corner, like we said before, oops, it says degrees in the corner. How do I change that? Right here, where it says radians, click it, and it changes to radians. Degrees, click degrees, and it changes to degrees. So what if this was in radians? What if this was pi? We still write the same thing, 0.6, I'm in radians, undo that 0.6, and that's going to be 0.92. And it's the same as degrees if I do the conversions. So that's what you guys are supposed to do in the homework. Let me do another one. If I give you the tangent of theta is, let's say, 1.3. I don't know what 1.3 is. That's not a special triangle to me. So we're going to take the inverse, tangent, inverse, tan of theta is equal to tan inverse of 1.3. The tangents go away. So we have theta is equal to tan inverse of 1.3. That's all calculator work. I want to make sure I'm in degrees here. So clear it, 1.3, tan inverse, shift, tan inverse. Oops. It's going to be 52 degrees, 52.43 degrees. Theta theta equals to 53.43 degrees. Now, one more thing I want to cover is what about reciprocal identities? If I write cosecant of theta is equal to, let's do 1.4, okay, 1.4. The problem is 1.4 first is not an not a special triangle, so I can't do this without a calculator. Looking here, I don't have cosecant. Cosecant isn't written on my calculator. Only sine, cosine, and tangent. Again, only sine, cosine, and tangent are used. So I can't use cosecant. So we have to rewrite cosecant. Cosecant is, let's rewrite this, is 1 over sine of theta. So 1.4 over 1. Just rewrite it this way. Can't stress, if you remember how to rewrite it this way, it's super easy. I don't want sine on the bottom, so you do a flip. Go ahead and flip it. So it'll be sine of theta is equal to the flip 1 over 1.4. We flip both sides. Once I flipped it, 1.4. All right. Now just calculator work. Theta is equal to sine inverse of 1 over 1.4. So you just got to type that into a calculator. So we can always change our reciprocal identities into a sine, cosine, tangent that we do know. Before I do that on a calculator, let me give you another one. Right, secant theta is equal to, say 1.8. So it's 1 over cosine is equal to 1.8 over 1, right? We're just writing them in fractions. You go ahead and flip it. Cosine is 1 over 1.8. So theta is the inverse of cosine of 1 over 1.8. So let's do these on a calculator. 1 divided by 1.4 equals, and we're going to undo our sine, I think. You said sine? Yep, sine inverse. Let's give us 45.58 degrees. Theta is 45.58 degrees. Let's do the cosine. 1 divided by 1.8. Yep, I'm going to take the inverse, the cosine. That's going to give me 56.25 degrees. Theta is 56.25 degrees. Okay. Just be careful. If they ask you for the answer in radians, you have to switch the setting on your calculator to radians.